So variable basis, part one, let's just quickly review the exponent laws with variables this time. So product of powers, okay, now it's powers with the same base, you add the exponents. Power to a power or power of a power, quotient next. Quotient, when you divide powers with the same base, it could look like this with the division. You could have the division bar, and you subtract the exponent, so the upper exponent minus the lower. And the important thing is the base cannot be 0 because you're not allowed to divide by 0. Power of a power or power to a power, a to the m to the n, we multiply the exponents. 0 exponent is equal to 1. Anything raised to the power of 0 is 1 unless that thing is 0. So the base can't be 0. Power of a product, you just raise each individual part. It becomes the product of the individual powers, right? So you do power to a power to each part of these, and then you take their product and multiply. Power of a quotient, the same deal. You do each part to the quotient, and then you divide, and the denominator can't be 0. You're not allowed to divide by 0. A negative exponent, if there's a negative exponent by itself, you can think of it as over 1. You then flip it, or you take its reciprocal, becomes 1 over, and you change it to a positive exponent. And if you have 1 over, and then there's a negative exponent in the denominator, it moves up to the numerator. You don't have to write the denominator, which just becomes 1. Okay? So those kind of go away, but that's sort of what's going on. And if you have a rational expression, if you have a fractional expression to a negative exponent, then you take the reciprocal, you flip it, and you change the exponent to positive. A fractional exponent, m over n, the bottom number is the root, so it is the nth root. Make sure that the n gets written in the index, unless it's a square root, then it's not needed, but make sure that it's pretty clear that you're going through, instead of going like 3 square root 12, right, you want cube root 12. If you mean cube root 12, make sure it looks like a cube root and not the 3. And then some ambiguous stuff is like this. It's a smaller 3. It's close to there, right? Or it's that, you know. So just make sure that it's clearly in there, okay? So if I show it to somebody else, I could just ask it to another teacher, what do you see this as? And they'll say 3 times the square root of 12. And it's like, oh, well, should have been the cube root of 12, right? And then generally, if you're doing it, evaluating without a calculator, you're going to take the root and then raise it to the power. Otherwise, you can do the root of a power like that. You can take the power first and then do the root. So if we look here on the left-hand side, we have a numerical base of 2. You do brackets first, right? Brackets, then exponents. So the exponent is out here. So we do the brackets. It's 2 to the negative 7 times 2 to the 5th. Negative 7 plus 5 is negative 2. In this case, it's over 2. This is a 1. It's going to be negative 2 minus 1. We've got a quotient. Negative 2 minus 1 is negative 3. And then power to a power, we multiply the exponents. We get 2 to the negative 12. We are asked to express it as a positive exponent. It's 1 over 2 to the 12th. If we are asked to evaluate it, it'll be 1 over 4,096. Okay, so if it says evaluate, your final answer is 1 over 4096. If it's express your answer with positive exponents, then 1 over 2 to the 12th. If it's a variable, so in this case, instead of a 2, we now have an x. We do the same thing, right? The laws still apply. Power, product of powers, right? You add the exponents. Negative 7 plus 5 is negative 2. I'm dividing. If there's no exponent there, it's a 1. Negative 2 minus 1 is negative 3, and then power to a power. Expressed with a positive exponent becomes 1 over x to the 12th. You cannot evaluate it unless you're given a value for x, right? So if they want us to evaluate, they're going to have to give us a value for the x. Okay, the base of the first power in the example is what? How does the base of the first power compare to the second? So the first power of the base is a number, and the second power of the base is a variable. Okay, so the base of the power in the first example is a number, And the base of the power in the second example is a variable. All of the same rules for exponents apply for simplifying, right? As long as the bases are the same, right? So that's the important thing. However, when we simplify powers with variable bases, we will arrive at an expression that involves variables rather than a so if it's a numerical base, we can get a number. So if there's a numerical base, we can evaluate this and we can get a number. You can actually work out what the number is, right? So in this case, 1 over 4,096. And in this case, expressed with a positive exponent, just 1 over x to the 12th. Simplify the following and write answers using positive exponents only. Okay, what does order of operations say? Do what?
Brackets.
Brackets. Then what?
Exponents.
Exponents. Okay, so the first thing we do is just say, hey, in this expression we have an exponent, we're going to do the exponent first, right? We're going to leave this alone. Although, what can I do with the b to the 0? Just make it 1, right? So 12. If you want to put the 1 there, then somebody looking could say, looks like you replace the b to the 0 with a 1. And then, what are we going to do here? Put the 2 throughout, right? So it's product to a power. So we go 3 to the 1 to the 2, which is 3 squared, and b to the 6 times 2, which is b to the 12. Okay, then on the next line we can simplify further. So I've got 12, and then here I've got 9b to the 12th, and then multiply and get 108b to the 12th. I would be okay with you going from the first line here, from the original question down to this, to just going 12 times 9b to the 12th, and then getting the 108b to the 12th. So if I want to see some work, that's the work I want to see. Okay. It says determine, right? Just don't come up with the final answer, right? Anybody looking at this might want to know where did things come from. Okay, 3x squared times 4x squared y, and that's cubed. What should we do first?
No.
We should cube the 4x squared y, right? So equals, so we're just going to write 3x squared. I'm going to put down a set of brackets in which we will now do the cubing. So what happens to the 4? So 4 cubed. What happens to the x squared? Okay, x to the 6th. What happens to the y? Y cubed. Okay. So show that, right? Showing that doesn't hurt. Okay, and that's equal to 3x squared times, and now you can write 64 x to the 6th y cubed. Okay, or another way would be just to really put this in brackets and then leave this in brackets, right? Writing brackets next to each other says to multiply. Okay, and then you can multiply 3 times 64 is 192 x to the power of 8 and y to the power of 3. Okay, it says determine. What does determine mean? Show your work. Essentially, determine's got a bigger meaning than that, really. But for us, the essential meaning of determine is show your work. Okay, next one. Are there any exponents on the bracket? No. Okay, so we could just go multiply 5 times negative 3 is negative 15, a to the power of negative 3, so we have negative 9 plus 6. And negative 15, now it says express your answers using positive exponents only, so it's going to be negative 15 over a cubed. Okay, moving down. Okay, what do we want to do here? So the instructions here pretty much always are simplify, right? Simplify. If it's evaluate, that means come up with a value. If it says solve, that means that there's an equation. You're going to come up with a value for a variable that makes something true, right? So 2x equals 4, solve, it becomes x equals 2. So the only time you can get a value for something is if it says solve or it says evaluate, which means they would have to tell us what x and y were, and then we would simplify and then substitute. Okay, that actually comes later. Okay, so to do this, I can split off the numbers. Okay, if I want. You don't have to do this. You could just straight write -2. Okay, but you can also do this and then say x to the 2 minus 1 and y to the 1 minus 3. So what I'm doing in the simplifying is I'm using the exponent laws. So first I'm just separating out the numbers. So it's -10 divided by 5. X, it's a quotient, so we go power 2 minus 1, and then we go y to the 1 minus 3. This gives me -2, x to the 1, y to the -2, which says it's -2x over y squared. I'm going to keep the negative out front by itself. Okay, and then put the 2x up top in the numerator and the y squared down in the denominator. Okay, so that's one way that you can do this. Okay, it's not the only way. So here's another possible solution. You can look at this and you can say -10 divided by 5 is -2. I've got an x squared and an x to the 1. Who's bigger? X squared. By how much? 1. So then I put an x to the 1 up top, right? So the bigger one wins, and it wins by how much? Y over y cubed. Who's bigger? Y cubed. By how much? By 2. So we go down to the bottom, and we put the winner at the bottom, and by how much it won. So -2x over y squared. Okay. So often simplifies like how much work are you showing? In this case, you're not really showing any work. You're just doing it. Okay. In the other case, you're showing the work. You do what you feel comfortable doing. If it's worth 1 mark, it's probably just a mark for the answer. Okay. If you show some work and you get the answer wrong, you can maybe pick up a half a mark because, you know, like the work you showed is correct, but then your final answer is wrong, but I see you would have got the correct answer. If your final answer is just wrong, you're just going to lose the mark.
So it's wrong if it's like -2x and then the line goes all the way under all the way? Yeah, like that. Is that wrong?
It's correct, but it's ugly. Okay. Actually, sorry. It should look like that.
Oh.
Okay, but the 2, you can really write it like this. Okay, that's kind of wrong too, right? It's not wrong, but this is the best.
Oh, okay, got it.
Like that. So yeah, you're right. The way I wrote it was yeah. So yeah, don't get sloppy with. You're better off doing this. Don't get sloppy with. I got a little sloppy there. Thanks for pointing that out. This one is just a bit. I just don't like the negative up top. I'd rather have this with the negative sign up front. But yeah, thanks for pointing that out. It's a bit of a sloppy answer. So this would be your preferred form. Okay. So the negative of, and then 2x over y squared. Okay, this one, what could we do? We can simplify what's in the brackets, right? You can say, hey, so 8 over 6 is how much? 4 over 3. H to the 5th is bigger than h squared by 3, so we can write an h cubed there. So we can simplify what's in the brackets. Throw an equal sign in front. So you're saying that when you throw the equal sign down, you're saying, whatever I'm about to write next is equivalent to whatever is above. Okay, and if you look at this, 4 over 3 can be made into 8 over 6, and the h cubed is equivalent to that. And now what do? So now we square it and get 16h to the 6th all over 9. Right, nice long fraction bar. So 16h to the 6th is clearly in the numerator, and 9 is clearly in the denominator. Okay, another way you can do this is to, in fact, square. Get 8 squared, h to the 10th. Okay, so here, 8 squared, h to the 10th over 6 squared, h to the 4th. So 64, h to the 10th over 36, h to the 4th, and then reduce this, and you'll get 16h to the 6th over 9. I don't like that, right? It just makes it overly complicated. So I think it's nicer if you can simplify this first, simplify it, and then square it. Okay? It makes things a little bit easier. However, it's likely just 1 mark for the answer. Okay? How you got there, it's up to you. What can we do with this one? So we can simplify the numerator, so we got x to the 2. So you can write it as 2 plus negative 7 if you like, over x to the negative 6. So that's x to the negative 5 over x to the negative 6, which is x to the negative 5 minus negative 6. This is like way more than I would probably do, right? But it's optional, you can do this. Okay, is equal to x to the negative 5 plus 6 is equal to x to the 1, or just x. Okay. So that's one possibility. That goes a little beyond what I think is reasonable. It's like, yeah, you're showing work, but that's really a lot. Here's another possibility. So you just do it all at once. You say it's x to the 2 plus negative 7. Now, when you say plus negative 7, just write it as 2 minus 7. Okay, and then minus negative 6. Okay. Actually, no, let's write it. So 2 plus negative 7 minus negative 6. So that's going to be 2 minus 7 plus 6, which is x to the 1, or just plain old x. Okay, so because you've got product of a power, you're going to add exponents, then you've got a quotient, you're going to subtract. So these two guys are going to get added, and then this guy gets subtracted from it. I would want to see this as a final answer. Probably if I said determine, 1 line in between, at least 1 line in between. Okay, something like this would be fine, 2 minus 7 plus 6, and then x to the 1, or just x. Okay, remember, determine means show your work, so you've got to justify your answer. If you just write x, it's kind of like, okay, but how did you get that? What's this guy? So I would start off, it's power to a power, so you're going to multiply exponents. Right, so negative 4 times a half is negative 2, but it says that your answer should be expressed with positive exponents. So b to the 4th over a squared. This guy, showing work, 7 times 3 is 21. 3/5 plus negative 1/5. 21h to the 2/5. So if it said, and I don't think it does, but if it said convert it to radical form, what would this be in radical form? In radical form, 21 yeah, that. So 21, and then the 5th root of h all squared.
It's x.
Oh, where did I get h from? Okay, now it's h. Well, it's like, what's easier to change? It's okay, if you're watching this online, yeah, now h is. Or alternatively, you can square the h and then leave that off. Okay, fine. Okay. So 21x to the 3/5 minus 1/5 is 21x. Right? Like, that's the answer. That's as far as we were expected to go, right? But on the test, we will have to convert. So 21 5th root of x squared would work, or 21 5th root of x all squared. Make sure that goes in parentheses then, and then you square it, okay? So if asked for radical form, if asked for radical form. So read the question, make sure you understand what it's asking for, because it may say if the exponent is a fraction, that you are to express it in radical form. Okay, I don't think this does. Oh, that's where I got it from. Okay, so what do we end up with? What can I do to make this easier? Convert the 4/5 into 8/10, right? So here's the deal. We know we're working with exponents. We know we're going to have to, in this case, subtract, because we're dealing with a quotient. If we're going to subtract fractional exponents, they have to have the same denominator, right? So we can change 4/5 to 8/10. Then if we say, well, okay, who wins? The denominator. By how much? 5/10. What's 5/10? 1/2. What if I want that as a radical? So don't, the 9, right? The 9 is by itself. There is no exponent. Not entirely true. If there's an exponent on the 9, what is it? It's a 1. So the 9 is not affected, right? There is no exponent on the 9. At best, you could say, I suppose, it's 9 to the -1, so it became 1/9. But, the square root here, the 1/2, does not affect the 9. Don't start taking the square root of 9, like writing this as 3√h. Okay? It's not square root of 9. It's not in brackets. It's not like this, right? If it's in brackets like that, then yes, now it will become, well, actually, no, it won't, because you'd have to split it out. You'd have to do power to a power first. So the exponent on the 9 wouldn't change if there were one. Okay. So any questions about this? Common denominator. You could do, here's an alternative, equals h to the 3/10 minus 8/10 over 9. Don't touch the 9. There's no exponent on it. So h to the -5/10 over 9. 1 over, and then you change this, okay, which becomes 1/9 h to the 1/2, and then etc. if you wanted to change. But it didn't ask for radical form. Okay, give this one a shot, see what happens. Order of operations says you're going to do what first? Brackets, but there's really nothing to brackets. So you're going to do the exponent on the brackets first, right? So you want to square that first set of, you want to raise that first set of brackets to the 4th power, then square that second set of brackets, and then just leave the third set of brackets the same. So your next line, I would keep the brackets, but I would do power to a power on the first set. I would square the second set, and I would leave the third set the same. Okay. So when I'm squaring, that's a negative inside the bracket, so it's -3x cubed y times -3x cubed y. Okay. So it's the -3 that gets squared. Okay. Think about what this means. -3x cubed y times -3x cubed y. Okay. -3 times -3 is +9. You get next to the 6, you get a y squared. Okay. So you can always go back to first principles. What does it mean to square something, right? Just to multiply it by itself. And then And then as far as work goes, really, you don't need to show too much. It's good. I got it. It always feels good when you get it, right? Hey, I got the answer. It's amazing. Okay, next one. What do we have to do first? So you're going to have to cube this first, right? Can't do anything until this is cubed. So the negative 2, m to the negative 1, n cubed stays. Okay, now you can cube this, so what's going to happen to the negative 3? It's going to become negative, right? Because you're cubing a negative, you'll get a negative. 3 cubed, which is 27, m to the 9, n to the negative 12. So power to a power. Okay, now we can multiply. So positive 54, m to the 8th, negative 1 plus 9, and n to the negative 9. So 54 m to the 8th over n to the 9. Make sense? Any questions on that one? Okay, so we'll have a bunch of time to work on this in a couple of minutes. We have one more question, Karen. Simplify the following expression first and then evaluate. Okay, so evaluate, come up with a value, but first we want to simplify this. So the 6 is there. We can do the old who's bigger and by how much. We can just do it with exponents. So let's just do it with exponents. So 3 minus 1, negative 2 minus 1, and 5 minus 3. Right? So you're doing quotients. It's going to be the top exponent minus the bottom exponent. We're now going to simplify these guys. So 6a squared, b to the negative 3, c squared. Okay, then we're going to go with positive exponents only, especially because we're going to evaluate, right? And 3 to the negative 3 is meaningless. You can't multiply 3 by itself negative 3 times. So remember, when we're simplifying, the first thing we're going to do with negative exponents is turn them positive, right? So that you can do something with it. Fractional exponents often go to, we'll say when a equals 4, b equals 3, c equals negative 2, we have 6 times a, so that's 4 squared, times negative 2 quantity squared, all over 3 cubed. Okay. And there's no equal sign there, it's just when we substitute these values in, okay, and then we can work it out. So 6 times 16 times 4 over 27. Oh, which is 6 times 4, which is 400 minus 16. So 4 minus, like 384. So 384 over 27. But there's a common, so that could have been 2 and that could have been 9. So now we got 8 times 16, which is 80 and 48. Is that 128 over 9? So at some point, right? I mean, you got calculators. If you get 384 over whatever, just go 384 divided by whatever, math, enter, and it will give you the reduced fraction. Okay? So very easy to get down to a reduced fraction at the end if need be. Okay, so simplify first, use your exponent laws, okay, and then evaluate, come up with a value by substituting in the values of the variables. Okay. That's why I'm not writing an equal sign here. This isn't equal to anything. It's when this, then the expression becomes this, which is now equal to this, which is now equal to this. Okay, and then the exercises, which are for homework, so you've got the next little while to work on.